Okay, check answers, guys. For the first one here, what do you have? Which statement about magnet is correct? It attracts gold rod. No, it does not attract a plastic rod, obviously. So answer is B, right? This one. A student wishes to make a permanent magnet. She has an iron rod and a steel rod. Which rod should she use? Obviously, permanent magnet must be made of what? Good, steel, because it is a part of soft metal. Good, C. Okay, then this one here is basically induced magnetism, right? If I have a north here, here will be south, and naturally here will be north, and naturally here will be a south, and naturally here will be a north. So my P should be a north, my Q should be a south, and they are obviously supposed to attract, right? So answer is A. And after that, it's the same repeated question. So it's steel and hard. Okay. Which statement about magnetism is correct? An unmagnetized bar magnet becomes magnetized when it's placed near a magnet. This one could be possibly correct. A magnetized steel bar can be magnetized by passing through a current through it. Not enough. It has to be large current. The direction of the magnetic field is from south to north. Definitely no. The north poles of two magnets attract each other. Definitely no. So A is definitely the answer here. Okay. In which pair are both magnetic? Always look for the one which is iron and steel, which are the most common answers. Okay, so obviously it's C. This one here, you can see that the magnetic field are going outwards, then obviously it should be north and north, which is C. Right, the magnetic fields are like springing, like flowering outwards. Right. And next part here, this one here is a very interesting question. How many of you guys did this one? What do you get? You? How do you get C? How do you get C? How? What was your thought process besides common sense? Oh, very good. Yeah, he's the only one that got it correct. Guys, when you see this question here, you're supposed to understand that the current is coming out of the page, right? Then with your right hand grip rule, your thumb should be pointing out like this, right? That means to say your magnetic field will be in a what direction? It will be in an anti-clockwise direction, right? This magnetic field that is in an anti-clockwise direction should point the compass in the anti-clockwise direction also, which in this case is none other than C. This is your thought process. Excellent job.
What? Over here.
Non-ferrous materials. Which one? Like I said, as soon as you see the word iron and steel in it, it's for sure ferrous. So B is the only logical answer here. All right. And then this one, finally, question 12. What do you think? Catch up. What's the answer here?
Especially both. Wow.
Good answer is A. Guys, let me iterate this question also. A lot of students are, especially the Chinese educated one, they'll think that closed is off and open is on, because it's literally the exact translation from Chinese, Taiwan, right? Which a lot of students tell me open is on, right? So the nails are going to jump up, and then the nails is closed and the nails will fall out, which is exactly not it. Welcome, Natasha. Did you just come back from school? You didn't go to school. Then why are you late? What tuition that you have every day? What tuition are you having? Chemistry. Oh, interesting. Okay, so answer is A for this one. Then moving onwards to this next part here. Okay, if you look at this question here, it says that the physics teacher suspends two pointers in the magnetic field. One pointer is made from brass, another one is made of magnet. She holds the pointer in the initial position shown in two upper circles. She then releases the pointer. So basically, I have one brass pointer here, one magnet here, and they are placed in a very strong magnetic field as shown here. Right. So what's going to happen to the brass? Then what's going to happen to the magnet? Will the brass be affected by magnetic field? No, so it will not be affected lah. So it's still gonna be in its original position, right? But will this magnet be affected by a stronger magnetic field? Daisy, will it? Yes or no? So if it's affected, which one will point up and which one will point down? Think about it. Right now, I have magnetic field going upwards. Will this north pole point up or will it point down, and why? South is up.
Yeah.
Why?
They already. That's what you said.
It always points towards the south.
You said magnet, but I thought it pointed towards the north, right? You said magnet are very often from. What's the
The north pole of the magnet points towards the magnetic south of the earth. But that's not related to this one here. This one is literally in another magnetic field. So why would the side point downwards? What? Because of what? I can't hear you. Very good. Okay, that is one way to look at it. There's two ways to look at this question, guys. It's either number one, that you identify that this is the magnetic field, right? That means you say this is a very strong north and this is a very strong south, right? Then obviously this very strong north or south will attract the opposite poles, right? So this is one way to look at it. The second way you could look at it is also remembering from last week that these stronger magnets are going to influence the weaker magnets, right? Remember, I've said this last week, right? And if I have a stronger magnet that's pointing outwards here, this north pole will be pointing outwards here also. Because once again, if you look at it the other way, this is the north pole and this is the south pole. That's why this north is attracting this south. That's why the weaker magnets will always align in the direction of the stronger magnet. Okay. Understand? Justin, I feel like you're half here, not half not here.
Thinking about.
To the magnetic south of the earth.
Yeah.
Which is the north pole. What?
Where's the north pole?
That's a very good question, which I never really thought about before.
And here, right, the question you could and the arrow comes out, does that mean it's like I say that is what it means that it's
No, the magnetic field is going up. Dude, they literally look at the arrow and they know the direction.
You said the field.
Wait a minute, bro. Are you telling me you don't understand this part here? If I have a north and I have a south here, right? Where is the arrow pointing? The magnetic field, where is it pointing?
No.
Are you serious?
Read each other.
Bro, are you serious?
Those are not.
Bro, the magnetic, listen up, listen up, okay? The magnetic field will always point from the north towards the south. The magnetic field, this one here, will always have its direction going from north pointing into south. This is like the basic understanding of the magnetic field chapter first. Okay. Being looking at this diagram, you drew it wrong.
No, not that. I think it's not that. No, it's not.
Look, this theory is in line with all the other drawings that we have been drawing all this while. North, south, magnetic field. North, south, magnetic field. This one here is explained by this part here, right? The magnetic fields have no end. They continue through the interior of the magnetic field. But when we look, right, we don't look at this part, right? We don't look at this part. We always look at this part, right? Which is north to south, bro.
I got a feeling. Okay, I can just set it up. I they do the. Look, it was very stupid. Huh? Shut up. It was kind of weird in my head. Something.
Okay, good. But now we are clear. It's north to south. Okay, and with that new understanding, does this question make sense to you right now? Because like they already tell us that this is the magnetic field, right? That means to say what pole will be here? Good. It will be here. South pole here. Then that's why if I have a magnet, then naturally the south will be attracted to the north and the north will attract to the south. Or you could say that this weak magnet will be influenced by the stronger magnetic field, which will point it upwards. Good. Yes, I actually appreciate that more. Because you actually clarify what you don't understand, then you actually learn something here. Although I didn't say that. I didn't say that. I didn't say that. Don't put words in my mouth. No. There's no stupid questions in the classroom, okay?
No. That's not.
How's your phone situation going on right now? Okay. Anyways, back to this part here, right? Explain the final position of the brass. How do I explain this? What should I say? Why would the brass not be affected? Brass is what? Yeah, good. Brass is the non-ferrous material. It's not affected by the field. Daisy, you joined the chemistry class also, right? For what? You like physics more, right? That's why you dive into the next class. Okay, anyways, moving on next. Explain the final position of the magnet. How do I explain this? Huh? No, you can't say it's ferrous. It's literally a magnet already. It's for sure magnetic. In fact, powerful the magnetic field. How do I explain this? Why would it point upwards in the north and south direction? Why?
So 500 years ago. You gotta stop the machine. Magnetic law.
Oh, wait, after. Sorry? North points to south. No, that's not a very good.
Follow the magnetic.
Good, that's a closer answer. You're supposed to say that the weaker magnet is affected by the stronger magnetic field. Okay, or you could say it's influenced by the weaker magnet is influenced by the stronger magnetic field.
That's not a really good word. Like, don't need to be both of change. It's not that really from this go. You know what I mean?
Shut up, man. Shut up. Shut up. Shut up. Shut up. Stop, sorry. Natasha, suggest the material the magnet is made of. What should it be made of? Huh? Still. Oi, why do you stick my glass? Okay. All right. Okay, moving on to the next part. Figure below shows a vertical current carrying wire passing through what? A point X. Okay. And then from here, they ask you to sketch the pattern of the magnetic field. How? Why don't you sketch it? You're okay. How are you?
Very good. Like, direction will come in different directions. This is what exactly you're doing. Current weight balance, all right, so how many directions do? Okay. And so, what are you talking about? But it doesn't move in simple on paper, take gravity around paper, that makes so much. My question is, this also goes on the paper, take gravity around paper, so this also goes on the paper. You tell me how. What's this arrow? It's like sound. It's very. Oh. Oh, yeah. People I think that room for what we need for everything. No. I have. You understand? So we, yeah, so direction. Yeah, well, why it's good. Oh, suppose. Oh, I would already said, you see, X, Y, and Z, they don't. Okay, I'm gonna send you a video, right? You better open. What the becomes the point to look the diagram of the thing, right? It's a problem. But if the line is going down, the comment point.
Yeah, correct. 7 days ago was the 19th. Yes. Wait a minute. Did I share this to someone? Oh. I can only it's something. Wait, so that or you are coming laws. No, you'd be surprised if you want to share that, but I mean, Yeah. In India, the parents train their kids after watching the potty dog, how the potty train your dog. Then they train their kids to shit not onto the floor. Shut up lah. Please lah. Watch it. Go on and watch it. If not, you'll be good. This is a very important chapter, by the way. It's like the foundation for the next few chapters that are very hard.
Yeah.
Go home, watch it. Okay, anyways, I think everyone here knows this by now. But first and foremost, you need to identify that this arrow is by basically the current that's flowing downwards. Right. And because it is the current flowing downwards here, what's happening is you need to use your right hand grip rule and you need to point downwards. Right. And when you point downwards, you realize that, oh, my 4 fingers are rotating in a clockwise direction. Yes. Yes. Then after that, you find out that, oh, my magnetic field that is generated by this current will be in the clockwise direction. So when you draw this magnetic field, which you'll be commonly asked to do so, you need to know that you need to draw at least 3 circles. You must draw at least 3 circles. Yeah. It's like, I think it's written somewhere in the mark scheme. Yeah. So at least 3. At least 1 arrow. Okay, and then moving on to the next part here, using your knowledge of investigating the magnetic field around a bar magnet, suggest an experiment or experiments to confirm that you have drawn the correct pattern and direction in A1. So how do I determine the pattern and direction of the magnetic field? Justin, how do I determine the pattern first of a magnetic field using what? Good, very good. You're supposed to sprinkle the iron filling and then tap onto the paper gently to determine the direction of determine the pattern of the magnetic field, right? Then after that, JC, how do I find the direction of the magnetic field? Okay, how? How do I determine after I sprinkle the iron filling already? How do I know it's going to go from north to south? What do I do? No, nothing to do with iron filling already. Very good. I'm supposed to align the compasses around the iron filing. This will help me determine the direction, guys. So there's 2 parts to this. The first 2 marks, you're going to say that you're going to sprinkle the iron filing, right, and tap gently on the paper. This will help you determine the pattern of the magnetic field. Then the second 2 marks is after you have the pattern, you're aligning the compasses around the magnetic field to confirm the direction is from north to south. Essentially, this whole part here. Okay, for those who have not written down, write this down right now. Yep. Do everything ready? Very good. Excellent job. My model student here, guys.
Moving off hand. We want this. Yeah.
Dark. Seriously, you have the benefit of the dark today because
Here's the sound. Supposed to place the. And cool, what, if we only have one, first, then you, that's it, right? After that, only line is south to the, and you put the ball on the, because you actually do that. Oh, those private percent, this I think so much. And we go create a dynamic class, we must set interesting data. Create a. Then this one like do it. Okay, yeah, everyone. Oh, you take Daryl. Pick up the call and take, depending on the. Somebody do it or not. Jolly. Hello?
To the final two parts here, this part is a theory question of the, right, yeah. This part is a theory question. A second current carrying wire is inserted vertically through the cut at Y. Suggest why now there is a force on the wire X. What does this first statement mean first, guys? What does it mean? Okay, very good. So basically, but that's not what the first statement. First statement says that there is a current right now flowing through Y here. Okay, there's the exact same wire, like this one here, right? But this time it's flowing through Y. And because there is a current flowing through here right now, then what that means to say that it will generate its own magnetic field, right? It will generate its own magnetic field here. And as you can see, guys, can you see that right now these magnetic field they are going to intersect? And when they intersect, it means to say there will be either a repulsion force or there's going to be an attraction force, right? This gives rise to the force generated in this question here, guys. So they ask you to suggest why now there is a force on X, because you're going to say something like the current in Y generates a magnetic field that interacts with the magnetic field from X. Okay, I repeat, guys, you have to know what I'm saying. Don't just remember the words. The current from Y generates its own magnetic field, which interacts with the magnetic field from X. Somewhere along these lines. Generates a what? Magnetic field, which interacts with the magnetic field from X. And then the last question. Smaller grade of same atomic line. Why? So still exactly. For the distance, there's a relation to our terms. But here, 1 year for smaller. Why? Go for you guys. Smaller same or larger than mine. Why? Very good. That's the correct answer. You went smaller or bigger or why? Why? Good. Because it's further away right now, guys, and Z is further away, so the magnetic fields do not interact as much, and thus it is smaller. Yay! Anyways, exercise week.
Why isn't it come back?
Oh, this is supposed to be a program for the students to do the exercises every day, but a lot of questions has been since removed. So one is a very good and simple exercise though, I feel.
I think one.
Wait a minute, how many of you guys are here today? Okay, we'll do. Shit, it's not 5, it's 6. We'll do this in 15 minutes and then we'll discuss upstairs. Oh, by the way, you guys asked why I'm watching those stupid videos, right?
What's it?
The
dog.
I'm getting it off.
Hey! That has nothing to do with dogs. Exactly. It's not the.
I didn't play it.
Sorry, well,
Okay, right?
are you getting this dog?
Yeah. I'm gonna get it tomorrow. See, so stupid this dog.
You have it, you bring it here.
I'll try, but I'll need to convince Gilbert first.
He's gonna be good. You just show him or not? I'm sure he'll be good.
Okay, right? My God, Mario. Yeah, actually.
On different mistake.
So every time people ask me what's his name, it's Mario. Yeah. Can you guys guess what breed is it?
Mexican.
Your mom. So let anyone change. Let anyone tell you otherwise. So let me see, right? We're gonna go get this dog tomorrow. Yes. Oh, dog.
I mean, it's like you can speak around and people. The option for magnet, it's magnet. What? Oh, I think. It's not you still be it's all terms of people. I think some
Okay, I need to just quickly describe to you what you need to know, okay? Then go on to the detail. Yeah. Okay, so basically, first thing we talked about was we learned about the properties of magnets. So, like I've mentioned just now, the only thing you need to know is that obviously there is north and south poles, number one, and number two is you need to know the magnetic field goes from north to south. This is the thing. Okay, why would they attract? Is because the magnetic fields connect and they attract together. Why would they repel? Is because the magnetic field kind of flower upwards, and then it cannot. That's why when you place two north together, always you feel that there's a visible pushing force because they are pushing out. Okay. Then after that, we learned about ferrous and non-ferrous. Ferrous and non-ferrous is just a fancy term to say magnetic field. Not all metals are ferrous. Not all metals are non-magnetic. So like common examples of non-magnetic metals are aluminium, lead, zinc, copper. For example, these copper wires here, if you place a magnet, it won't track, right? But these are very common examples of magnetic materials. Okay. This part here is what we call induced magnetism. Today, if I have a very strong magnet, right, and I place it near an iron bar, what's going to happen is if I place paper clips here, it will be attracted also on. Because the magnetic field is induced along the iron bar. Okay, so it's induced magnetism now. And obviously it will become opposite also. Like I mentioned in the it's not yeah. So here when you use the magnet, oh, this is the magnet or this is the magnet? Oh, this is the magnet, then this is the north and this is the south one. Yeah, so like this one is more. Yeah, so you see here, right? If this is north, right, here immediately opposite will be south, and here will be north. But if I slide it over to the other side, this is still north, but you see north and north is still here. Here is north and here is north. Right. But if I slide over here, right now this one becomes the south and this one becomes the north, because the immediate opposite will be the opposite pole. Okay. Then after that, we talked about permanent and temporary magnets. For permanent and temporary magnets, you need to know that permanent magnets are always made of steel, and temporary magnets are made of iron, because steel is a hard metal and temporary magnets is a soft metal. Hard metal means to say hard to magnetize, very hard to demagnetize. Soft metal means to say hard, easy to magnetize, easy to demagnetize. For example, this magnet here, if I don't touch it for the next 10 years, it will retain its magnetism. It's very hard to demagnetize. That's actually smashing it against the ground. And then these temporary magnets, as soon as I cut the current, here, right, they will turn back into an iron bar and easy to demagnetize. And yeah, this one here is a very long one. I lost the video. We need to teach. And this one is the one I talked about all this now. This iron filing and compass is basically used to determine the pattern and direction of the magnetic field. First, you put the magnet top, and you sprinkle the iron filing onto a piece of paper. After you tap the paper gently until all the iron filing set into motion. And after you have the pattern ready, right, you put the compasses around the pattern of the magnetic field. Then you will notice that you all point to this one here. They all point. So for north and south. Yeah. So I know that this is for sure north and this is for south, because the compass is pointing like this way. But you still need to want to figure. And this last part here is really talking about the direction of the magnetic field due to the flow of current in the wire. Usually, I know that a current is flowing through this wire here to generate its own magnetic field, and I can determine the magnetic field using the right-hand grip. This right-hand grip rule, this thumb is the direction of the current, right? And these four fingers will be the direction of the magnetic field. That's why you see, if my current is going upwards, right, my magnetic field will be anti-clockwise. Right? But in your exam, they rarely ask you in 3D. They'll ask you more in 2D. Okay, so they represent the direction of the current in X or in dot. Okay, X like the treasure, X means to say into the paper. The current is going into the paper. And if the current is going into the paper, you see the four fingers will rotate in the clockwise direction. If it's not, it means to say the current is coming out of the paper into your eye. Okay, out of the paper. X means to say into the paper, dot means to say it's out of the paper. And if you see the direction of the magnetic field, it'll be in an anti-clockwise direction. I think. So this how you can. But you still need to watch the video because that one is more detailed. So it's like 5 minutes, 5 minutes explanation. So go watch the video. For the purpose of this exercise, start doing it right now.
It was bridging between alternating
Alright. Yeah, alternating current will go from positive to negative. Like battery, right? Battery is a common example of the go with one direction from positive to negative. But alternating current will go positive to negative, and positive to positive, which is essentially what all these things combine. All these three parts are positive, negative, positive, what do you generate on any other? Is it like you having something that you want and speech? What is it? Yeah. The mathematician and the move from the syllabus. So you can choose the base. Really? Really?
What does it see? The AC power supply.
AC power supply is alternating current. DC power supply for your batteries is one directional current. So
Good. What do we do?
same issues for I think that these issues for
Fine. It's you. Okay. Oh, and so I'm stuff. Something. What? AC.
AC.
Oh. So I think that's the difference about thinking identity. Alright, I'm not happy about it. We use it like that and we're talking about yeah, hey, for the whole sentence is wrong. So I'm yeah, I'm always thinking about and so that most interesting high school experience was blowing up the lab.
Yeah, and then hospitalizing. You know what I did on the last day of school? I went to YouTube and I was watching how to make a smoke bomb because I'm thinking, I'm gonna get this school real good at something. But when I was in high school, right, I was like what's I was like the head of mischief, you know. Mischief, yeah. So nothing, right? Because I was quite friendly with a lot of people, right? So I always have like plans for everyone to do something done. So on the last day of school, what I did was right. I'm like, okay, we're gonna get to school for all the fees that we're paying for this. First, I even sat everyone down and say, first, we're gonna buy some flour, okay? Then after once this flour gonna be used for, we're gonna draw a really big stick onto the field. Okay, that's the first thing. Then after that, we're gonna buy some coloring. So we're gonna pour, and I said we're gonna make the swimming pool purple. And in order to make it purple, you need red and blue coloring. Okay, then we bought that. Then after that, I said, and the final thing we're gonna do is, oh no, sorry. Then after we're gonna buy some permanent markers. That's fun. We're gonna pull all this shit down from school and we're gonna fix it. And finally, for the banner, we're gonna make a smoke bomb and we're gonna show the people. Oh man, okay, sad. I'm picking up, but that's the best part yet. Everything got done already. For every material already, and started drawing fix onto the thing and everything, and then then pour the shit in because I had to make the smoke bomb on the thing. So I know because it was very good with my like this.